Large language models generate text, but out of the box, they can't actually do anything. They are isolated reasoning engines that require external tools to interact with the digital world. To execute tasks, these AI agents rely on two primary protocols to act as their interface with external systems. First is the command line interface, or CLI. Second is the Model Context Protocol, known as MCP. CLI is the raw language of the machine, and AI models already know it fluently. Because their training data contains millions of developer forums and Stack Overflow posts, they intuitively know how to string together standard terminal commands. MCP operates differently. It connects to dedicated servers that expose structured tools using a JSON schema. Think of this schema as a highly detailed instruction manual explaining exactly how a specific tool works. The catch is that this entire manual has to be loaded into the AI's temporary memory, its context window, before it takes a single action. Why force a model to read a heavy instruction manual every time it wants to execute a task if it already knows the native language of the computer? We can put both approaches to the test with a basic file operation. We'll ask an AI agent to search local Markdown files and verify a project status. This terminal window code block shows the CLI approach excelling. The agent immediately chains together standard bash commands, completing the read and verify process perfectly without needing any outside schema to tell it how a search works. When we ask an MCP server to perform a similar task using a tool like Git, the efficiency drops. The GitHub MCP server injects 80 separate tool definitions into the agent's memory, consuming 55,000 tokens before actual work begins. In the AI ecosystem, memory is money. Filling context windows with definitions the model already understands creates an expensive, unnecessary compute tax. For native computer operations like file management and text processing, hard-coded instinct outperforms rigid protocol. CLI clearly wins. But modern enterprise workflows are rarely that simple. Let's escalate the test to fetching and summarizing a modern Next.js web page. Here, the CLI approach fails. Standard terminal commands pull down an unreadable skeleton of JavaScript framework code because they lack the ability to actually render modern web environments. MCP handles this effortlessly. An MCP server deploys a headless browser to render the complex JavaScript in the background, filtering out the noise and handing back a clean, readable text document to the agent. Treecapital's Anven AI resolves this tension. Anven is built as a sovereign reasoning engine engineered to dynamically orchestrate both protocols. It uses CLI when raw speed is required and relies on MCP when it needs deep abstraction for complex environments. True autonomous intelligence relies on a model's ability to evaluate an operational gap and then dynamically select the correct tool to cross it. Moving these agents off a local developer's laptop and into a global enterprise network introduces a massive scaling problem, specifically around authentication and audit trails. If a system relies solely on a CLI agent, that agent must manually manage OAuth tokens and session states. This creates an unacceptable security flaw where sensitive authentication data is exposed directly to the model's processing logic. MCP shifts this control to the architectural level. Instead of the agent managing static credentials, the protocol uses a secure vault to broker access. The vault feeds a temporary single-session token to the MCP server, keeping master authentication records isolated from the agent's reach. MCP serves directly as the strict governance layer required to safely run autonomous agents inside a corporate environment. This level of governance is critical for highly regulated sectors like healthcare and finance, where data privacy and compliance are strict legal requirements. This graphic illustrates the contrast between standard models and Treecapital's Anven Enterprise AI. While generic AI operates as opaque, probabilistic generation, Anven provides a deterministic framework for enterprise use. Designed for air-gapped deployments, it guarantees absolute data sovereignty. Zero proprietary telemetry ever leaves your firewall. As shown on the left side of this architecture diagram, Anven scales this capability down to the edge. By utilizing optimized 3 billion parameter quantized models, compressing the AI for smaller hardware, it enables near-zero latency processing directly on local devices and SME software. The future of the enterprise market belongs to organizations that deploy sovereign intelligence. Companies will succeed by utilizing systems capable of merging the raw velocity of local commands with the absolute governance of structured protocols.